Hello, this is the second demonstration video in the OmniYacht Soft Hub Platform demonstration series. In this scenario, we'll present a slight variation on the demonstration presented in example 1. We'll introduce the use of timer objects as well as illustrate how state logic can be used to conditionally control the execution of Soft Hub rule objects. And as with the first example, after we build our configuration file, we'll actually load it into our device and do a quick live demonstration. In this example, we'll again connect to one ANT Garmin Tempe sensor and one Bluetooth Low Energy Texas Instruments sensor tag sensor. However, instead of forwarding every packet we receive to our AWS packet capture server, we'll only send the most recently received packet from each sensor every 30 seconds. Additionally, we'll only send packets between the hours of 9 a.m. and 5 p.m. So let's get started and build our configuration file. We'll start by opening our previous configuration file from example 1. We're going to use it as a basis as it already has definitions for the sensor stream objects and two action objects we'll also use in this example. We're going to delete the rule and event objects as these will be replaced with our new logic. So as before, we're going to use the Auto Start All Sensors system option to handle our sensor connections, and again, leverage on the sensor stream and action objects we've already defined. For this example, we'll need to add one additional action object. This object creates a continuous timer object which, once instantiated, will continuously queue the named timer expired event object at 30-second intervals. Next, we'll add two time of day state objects. When evaluated, the first time of day state object we create will be true only if the current time of day is greater than or equal to our threshold time of day, which in this example is set to 9 a.m. Next, we'll create a similar time of day state object, which will be true only when the current time of day is less than or equal to 5 p.m. With those three new objects in place, we can now create our new rule set. Generally speaking, event objects are created as a side effect of creating some other object. There are two exceptions, however, the app starting and the app stopping events. If required, these two need to be created manually. So we'll create an app starting event by right-clicking on the Events and Rules node and selecting App Starting. We give our new event a name and save it. Now we'll add a single rule to be triggered by the app starting event. In this rule, we have no conditional logic and only a single action object, which is our object to create and start our continuous timer. Next, we create a new rule that will be evaluated every time that timer expires. For this rule, we're going to add some conditional logic by clicking the State Check Edit button. In the State Check screen, we'll see all our state objects available in the State drop-down box. We can use them in conjunction with the Boolean logic operator buttons to create whatever conditional logic we want to place on the execution of our rule's action objects. In this example, we've created logic that will only be true when both the is after 9 a.m. state object and the is before 5 p.m. state object evaluate to true. Lastly, we'll add the two action objects to forward the latest Tempe and sensor packets to our remote server. We'll save that as our new ruleengine.xml file. And as before, we'll push it over to the Soft Hub using PuTTY's pscp command. Now we'll restart the Soft Hub daemon and switch over to our AWS server to wait for the packets to arrive. So as before, we have our ANT Tempe sensor and our Bluetooth Low Energy sensor tag sensor connected through their ANT and Bluetooth radios to the Soft Hub application running on the Raspberry Pi Zero. The Raspberry Pi is connected via Wi-Fi to our router and is forwarding packets every 30 seconds to our AWS cloud server. The laptop has a remote desktop session to our cloud server and is displaying the packets as they arrive. We're going to zoom into the video of the packets arriving to show that they will stop as the clock shows 5 p.m. Note that the AWS server clock is actually set to GMT, so its clock will actually strike midnight at 5 p.m. local time. For brevity, we'll fast forward the video to 5 p.m. Looking at the recorded video, packets had been arriving at exactly 19 and 49 seconds after the minute, but as you can see, no more packets are arriving. So as configured, the SoftHub stopped sending packets at 5 p.m., and if we stuck around long enough, we'd see it would resume sending packets again at 9 a.m. That wraps up our second demo video. Tune in for our next video where we'll demonstrate the SoftHub's built-in email and SMS capabilities, as well as show how to place thresholds on sensor data packet values to create alarms. Again, thanks for watching, and if you found anything unclear, please check out the download links in the video description to the SoftHub introduction and configuration manuals.